This chapter is all about conics. Now, what specifically is a conic? And from the dictionary, the definition is as an adjective, it means of or like a cone. Okay, there's 4 types of conics, but we're only going to study 3 of them. That 4th one is a parabola that you'll get into later. So how you create a piece of the cone is, notice that we have 2 pairs of cones. We've got them touching at the tip. The way you place your plane, so this rectangular plane, is going to create a different image where you put it within those cones. So the first one we're going to talk about is a circle. And a circle is when that plane is parallel to the base of the cone. It's going to form this circle. Okay, an ellipse is when you place the cone on a diagonal, that it elongates the circle, and then it would form an ellipse. And the last one is a hyperbola, and where your plane is going to be perpendicular to the base, or very close to perpendicular, where it cuts both sections of the cones. Okay, so there are some basic terms that we do need to know. The first one is a center, and we'll get into this tomorrow, but a center is technically HK. Okay, now if we go back up here, the center of a circle we've talked about is exactly right here in the middle where it would be equidistant from each side. Okay, so those radii would be the same. So the center is equidistant from each edge of the circle. In an ellipse, though, your center would be about here, okay? But if you notice, it's not equidistant, so the distance here would be a lot shorter than that piece. So your center is not equidistant in an ellipse. In the hyperbola, the center is between the 2 branches. So here's one branch, here's the other. The center would be right there. So each of those dots is the center. So I'm going to label it C just so we know. Okay. The vertex does not happen in a circle. So a circle does not have a vertex. What a vertex is in an ellipse is the end of your major axis. End of your major axis. And I'm going to put major axis in quotation marks because we'll get to actually what that is later. So if we look at our ellipse, our major axis is the longest side of that shape. Okay, so the smaller one is not the major. The longest line you could draw is your major axis. Okay, and your vertex is from one endpoint to the other endpoint. So I'm going to say this is vertex 1 and this is vertex 2. That's what it is on an ellipse. On a hyperbola, the vertex is the turning point. I'm going to put that in quotations again. Turning point of each branch. The turning point of each branch. So back up to our image. Here is a branch. The turning point would be like right there, and that one is there. So we'll call that vertex 1 and vertex 2. The focus, again, the circle has no vertex and no foci, which is the plural for focus. So the focus is a point at which distances are measured. A point at which distances are measured. Okay, so our foci on the ellipse would be in between vertex 1 and your center, and the same there along that major arc. So this is foci 1, and foci 2. And then for the hyperbola, it's in between, or it's inside that curve, okay? So it would be right around here and here, so that would be foci 1 and foci 2. So it's inside that turning point, and they're all along that same line right through here. Now, one thing we already talked about was the major axis. The major axis, we'll say, is the longer axis. We're going to go on and say it goes through the center and the foci. Okay, so I'm going to draw this in blue. Major axis, we drew it right here in the blue. Okay, and then the minor axis of our ellipse is perpendicular to the major axis and goes through the center as well. So our major axis was the long, our minor is perpendicular to that and goes through the center as well. So those are all the ports that we will be talking about throughout this whole chapter. We will keep referring to it, so it will become a little bit easier. Now, if you turn the page, we have something that says to work with conics, we have to be able to work with quadratic equations. Now, we have already learned quadratic equations, so one skill we will need to know before we start is the ability to complete the square in a quadratic equation. So what you learned back in algebra is that standard form for a quadratic equation is ax squared plus bx plus c equals 0. Okay. We will only be concerning ourselves with quadratics where a is 1, so that a value will always be 1. Okay. Now, when we solved a perfect square trinomial, we always have been doing this x. So we say what multiplies to 9 and adds to 6. So in this problem, we would say 3 and 3. So when we factor it, our answer would be x plus 3 times x plus 3. Another way we could have written this, because it is the exact same binomial, is the quantity of x plus 3 squared. So what we are going to be doing is this here is a perfect square. We are able to write it in this perfect square trinomial. So what happens if we don't have that c value? Okay, so that's what we're going to be looking for now. And if I tell you that every trinomial that we have can be made into a perfect square, you probably won't believe me, but it will. And it's only by finding one piece. And to find that c value, that last term in our standard form, we're going to take the b value. So this here is our b value right there. To find c, we're going to, in parentheses, say b divided by 2, whatever that b value is, divide it by 2 and square it. That will give you that c value. So, if we were looking for the c value, we would identify our b value. A would always be 1, so in this case, b is 16. To find c, we're going to take that b value we just found, divide it by 2, and then square it. Okay, so this again is helping us complete the square. So 16 divided by 2, remember we do what's inside parentheses first, is 8, and 8 squared is 64. So this is important that you do not skip this step, because this will be telling you something later on. So please do not skip this step. If we wanted to write our answer or our completed trinomial, we would say x squared plus 16x now plus 64, because c is 64. To write it simplified, after we would have factored it, we would say x plus, that's where this comes back in, 8 squared. So it's very important that you pay attention to this symbol and this value, because that's what's going to give you your answer here, x plus 8 squared. To show you that it works, 64 needs to be multiplied to, and 16 is added to. We all know that it's 8 times 8. Therefore, we can say this is 8 squared. The nice thing about completing the square is that it's just a pattern. Once you find that pattern, it's the same thing every time. So we have to, again, pay attention to our negative, but our b is negative 24. So to find our c value, we're going to say negative 24 divided by 2 squared. We're still following this equation. We would then say negative 12, because that's negative 24 divided by 2. And I cannot stress enough how important it is to keep these parentheses. Because when we're squaring, if you do not have those parentheses around when you have a negative, even a positive, keep them there, you're going to get the answer wrong. So please make sure you keep those parentheses. And negative 12 squared inside parentheses are 144. So our answer would be x squared minus 24x plus 144. To write it as a perfect square binomial, we again pay attention to our symbol. Here it's going to be a minus, and you take the number. So x minus 12 squared would be your answer. Okay, so this here is going to tell you what symbol is inside, and the number inside after you divide is the number that is your perfect square binomial. So what I want you to do is hit pause on your screen, go ahead and try the first two. I want it in trinomial form and then your perfect square binomial. These two problems, 1 and 2, are very, very, very similar. The only difference is that we have a negative here and an addition sign here. So it's going to change your answer just slightly. So after you find your c value is 1, your perfect square binomial would be x minus 1 squared, minus 1. Over here, because it's positive, our plus sign, our perfect square binomial will be x plus 1 squared. So again, hit pause and try problems 3 and 4. So in problem number 3, your b value is 14. When you simplify, you're going to get your c value is 49. So this would be your trinomial. Your perfect square binomial is going to be positive 7 squared. And then 4, b is negative 30, so you're going to continue. Remember, these parentheses are very important around negative 15, because if you do not have them, you'll get a negative answer, which would make this wrong. So you would have x minus 15 squared. Now we have one more part of this lesson to learn, so you can stop this video and go ahead and start the second video for the rest of the lesson.